All right, so this will be the second set of slides, starting with slide 21. Okay, so what happens if we have just pure water around? Well, since we've saw in the last set of slides that water can donate a proton or accept a proton, then what happens if you've got pure water is that we can have what's called self-ionization of water. Some of the H2O molecules will act as acids and will donate a proton. Some of them will act as bases and accept a proton. And so this is called the self-ionization equation. So you can see that if we have two waters, they can react to give us H3O plus and OH negative. Since it's a one-to-one reaction, in pure water, the number of H3O positive and OH negative molecules will be equal to each other. So, in 1 liter of pure water, the concentration of each ion is 1.0 times 10 to the minus 7th molar. This is a very small number, but very important. So remember, that's 0.0000001 molar. Very small number, but important. So again, in pure water, the H3O positive ion concentration, those brackets right there, mean concentration in molarity, equals OH negative concentration in molarity, which equals 1.0 times 10 to the minus 7th molar. Again, that's in pure water. Okay, so we can set up a mathematical expression that relates the concentration of the H3O plus and OH negative. If we multiply them by each other, we get what's called Kw. Kw, just K stands for constant and W stands for water, so it just happens to be the constant for pure water. And if you multiply 1 times 10 to the minus 7th times 1.0 times 10 to the minus 7th, we get 1.0 times 10 to the minus 14th, and that happens to be the value of Kw. So a constant is just a number that stays the same. Remember again that the brackets indicate concentration in molarity. Okay, now this is called the ion product of water because we are multiplying, in other words, finding the product of the concentration of each ion. So this equation is called the ion product of water. Okay, so if you have pure water, like we said just a minute ago, H3O plus concentration equals the OH negative concentration, and they both equal 1.0 times 10 to the minus 7th. Well, if the two concentrations of H3O plus and OH negative equal each other, we call this a neutral solution. They are equal to each other. We can say that it's neutral even if there are other ions present. So what we'll talk about later are salts. If a salt is dissolved in water, we can have H3O plus and OH negative equal to each other, and that would still be considered neutral. So a neutral solution, the term neutral, describes any aqueous solution in which the H3O plus concentration equals the OH negative concentration. A neutral solution is neither acidic or basic. Now this equation, the W equal to H3O plus and OH negative, can be applied to any solution, any aqueous solution. And one thing that we can tell about this equation is that it's an inverse relationship. What that means is, so if two things are multiplied together to give a constant, what that means is if one of them increases, the other one decreases. If one value goes up, the other one has to go down. And we can always find the value of the other one if we know one. We'll do that in just a second, an example of that. So a neutral solution is one where the two concentrations are equal to each other. If the H3O plus, which stands for acid, is greater than the OH negative, then we call that an acidic solution. And if the H3O positive is less than the OH negative, we call that a basic solution. Sometimes you'll hear the word alkaline solution. Basic. All right, so if we have this ion product equation and we want to find, if we know one of the concentrations, we can find the other very easily. So here's an example of a calculation. Calculate the OH negative concentration in a solution that has an H3O plus concentration of 1.0 times 10 to the minus 5 molar. Okay, so what we do is we set up our equation, 1.0 times 10 to the minus 14th, which is kW, equals H3O plus times OH negative. Now if we plug in the 1.0 times 10 to the minus 5 in for the H3O plus, because that's what we know, and we solve for OH negative, then we get 1 times 10 to the minus 14th divided by 1 times 10 to the minus 5th gives us 1 times 10 to the minus 9th molar. Now compare the two. OH negative is 1 times 10 to the minus 9th. H3O positive is 1 times 10 to the minus 5th. Remember that when you're talking about exponents that are negative, the smaller the negative exponent, the larger the number. So 1.0 times 10 to the minus 5th is a larger number than 1.0 times 10 to the minus 9th. So that means that the OH negative is smaller than the H3O positive, and so we call this an acidic solution. All right. Calculate the H3O plus concentration in a solution that has an OH negative concentration of 5.2 times 10 to the minus 10th molar. Again, and then classify it as acidic or basic. So again, there's our equation, 1 times 10 to the minus 14th equals H3O plus times OH negative. This time we know the OH negative concentration, so we plug that into the equation. Now we take 1 times 10 to the minus 14th divided by 5.2 times 10 to the minus 10th, and we get 1.9 times 10 to the minus 5th molar. This is still negative, so it's considered acidic. This time, when you look at it, it's 1.0 times 10. All right, now you've probably all heard of pH. pH is another way of describing acids and bases. Keep in mind, remember that H plus is just a shorthand way of writing H3O plus, and so throughout the next few slides, we'll just be using H plus rather than H3O plus, but don't forget that it means the same thing. So H plus still stands for acid, H3O plus. Now notice that those numbers have been really small. 1 times 10 to the minus 5th, 2 times 10 to the minus 10th, very small numbers. And so it's often easier to express the H plus in terms of pH. So what is a pH? Well, here's the official definition. pH equals the negative log of the H plus concentration. You might want to look at it rearranged later on. We'll see an example of this. If you rearrange this equation, now you know that if you're trying to undo an equation like and its multiplication, then you divide. Well, this happens to be the inverse relationship of a log. So an H plus concentration will equal 10 raised to the negative pH. I'm going to do some examples in just a minute. Now, how do we interpret pH? You probably have heard this before too. The pH of a solution, if it's equal to 7, that means it's neutral. H plus equals OH negative. If the pH is less than 7, that means that the H plus is greater than OH negative, so this is an acidic solution. If pH is greater than 7, that means the OH negative is greater than the H plus, and we have a basic solution. Here's just a pH scale that you can study later. Battery acid has a pH of down actually below 0, which is very, very acidic. You can see vinegar has a pH around 3, orange juice a little bit more than that, a little bit less than 4. Coffee is close to 5. Freshly distilled water is right exactly at a 7, although pure rain is a little bit acidic because it's got some CO2 dissolved in it. You can see blood is slightly basic, just above 7. Seawater is right around 8. Baking soda is just over 8, etc. So you can look at that. And in the bottom, you can see household lye has a pH almost to 14. So that's very, very basic. All right, so how do we calculate the pH? This is a kind of a hard thing to describe over the internet. And you may notice that I have posted some videos of someone actually doing, I don't know how to do this yet, but I've posted of someone actually going through a calculation of a pH on Blackboard. So you might want to look at that if you're still wanting to see what's happening. Anyway, if we want to calculate the pH of a solution where H plus is 3.6 times 10 to the minus 4, we're going to plug that into our equation. So pH equals negative log 3.6 times 10 to the minus 4. All right, so how can you do that? Well, there's different calculators. If you've got like a TI-84, a big, nice graphing calculator, it's very straightforward. You can just type it in exactly as you see it. You can hit the negative button, and notice that the negative button is not the same as the minus button. You'll see a negative button usually in parentheses, or you might see like plus minus on the same key. That's your negative button. So you would just hit negative, and then you would hit the log button, which like on the TI-84 just says log, and then you would just type in that number. And let me recommend that you use the EE button, which it may be either the EE button or the EXP button or something like that. And sometimes you might have to hit the second button to get the EE button. But if you hit in 3.6 EE negative 4, then you'll make sure that your calculator takes that as one whole number rather than two numbers. If you really don't know how to do that and you want to plug in 3.6 and then hit the times button and hit the 10 with the caret and the negative 4, make sure you put that whole number in parentheses. Otherwise, this won't work. Otherwise, you don't have to use the parentheses. They're just there sort of to make it obvious. Now, some people have a little bit cheaper calculators, and so you really need to get used to your own calculator. Some of them you have to work outwards. So in some of the calculators, you have to follow. You can follow these steps. You sort of have to start with the 3.6 EE negative 4, then you have to hit the log button, then you have to hit the negative button. Like the TI-30 is one example that you have to go outwards. Some of the cheaper calculators you have to do that. And you can follow through. So 3.6, and then hit the exponent button, either EE or EXP. Also on the cheaper calculators, you can't hit the times 10 with the caret. That doesn't work either. So this is probably a good thing to study. Then hit the log button and then take away the negative sign. Again, play with your calculator. You can get online, maybe find out how to do it, or if you have your instructions, or if you want to watch the videos on the on Blackboard. All right, here's an example of doing the opposite. Let's say you want to find the H plus concentration and you know the pH. Well, what you do is use the alternate pH equations. That's equal to H. Okay, so calculator and caret calculator. You may number, which you need to special button to decimal sign to. the calculator on an SL of the number 5 CI is active percent and calculates and calculator or the ones you obviously just go back later that carrot, get a or into and hit 5 minutes. As we got here earlier, you feel you can or instructions. All right, here's one more example. Household bleach has an OH negative of 5.0 times 10 to the minus 2 molar. What is the pH? Now, see that I've written be careful. Remember that pH is defined as negative log H plus. So, the first thing we need to do is find the H plus. Here we're given the OH negative. But we know how to do that. We did that a few slides ago. So, first thing we have to do is find out what the H plus is. H plus will equal 1.0 times 10 to the minus 14th divided by the OH negative, which in this case is 5.0 times 10 to the minus 2. And then we get 2.0 times 10 to the minus 13th molar, which is the H plus. Now we can find the pH. It's just negative log of H plus, negative log of 2.0 times 10 to the minus 13th, which will give you a pH of 12.7. And it doesn't say so, but that is a basic solution. All right, example 4. What are the H plus and OH negative concentration of a lime cleaner that has a pH of 12.4? So again, we use that other equation because now we know the pH, but we don't know the H plus. So H plus equals 10 to the negative pH. 10 to the negative 12.4 gives us 4.0 times 10 to the minus 13th. That's the H plus concentration. Now that we know the H plus, we can use the other equation, 1.0 times 10 to the minus 14th divided by H plus, 4.0 times 10 to the minus 13th, to give us the OH negative, which is 2.5 times 10 to the minus 2 molar. And that is the end of this. I hope that you were able to follow. Again, you might want to check some of the videos online for using your calculator or to find your specific calculator. If you're having trouble and you tell me what kind of calculator you have, I might be able to help you figure it out. All right.